Well, hello. It's good to be back after a long weekend and a Monday off. We're doing a couple of shows this week, which are dear to my heart. They're like old-fashioned intercom for us old people.
Old guys.
For us old people.
For a bunch of old-fashioned guys.
Exactly. And I invited Bob Tourkow to join us here. And most of you know me as Best Audio, and Bob Tourkow is the T in Best Audio. The name Best Audio stands for Dave Brand, Larry and Bob Estrin, Norm Schwartz, and Bob Tourkow. And this was the company that they started basically to do comm and production and audio and all this sort of stuff. And it went on forever. And Larry maintained the name Best Audio. And Larry has since passed away, and Norm Schwartz has passed away, and all that's left is Bob Tourkow and me. So, hey, I am perfectly glad to take over the E in Best Audio.
Well, Dave Brand might be upset that you said you and I are the only ones.
Oh, right. How soon they forget. I only spent an hour talking to Dave Brand yesterday. Dave Brand is another person who is used to be heavily involved in intercom. He's sort of semi-retired now. He's one of the partners in Intercom Systems with an S.net, and an absolutely fascinating company with all network-based intercom system written by John Jurius, who was the original author for Clear-Com's Digital Matrix, and had basically made the whole thing work on the internet. So we're going to talk about two-wire intercom, but I do have to say that were it not for Bob Tourkow, you would not be seeing me. I would not be on this webinar. Yogi Berra, a famous philosopher, once said, when you come to a fork in the road, pick it up. And Bob Tourkow is the fork in my life's road. I was a college dropout working at Columbia University for no pay to do concerts on the student radio station WKCR. And Bob Tourkow and the company he worked for, what was the name of the company?
Creative
Theatrical Services, right. Bob Kiernan's company was doing audio for a concert by the Kingsmen, formerly known as the Kingsmen, which was a barbershop quartet on Columbia University campus. And they had just changed their name to Sha Na Na, and this was a concert on the steps of Low Library at Columbia University. And he gave me, he was mixing the whole show on 3 Shure SM68 FC mixers, maybe 4, but I got 3 feeds from him, and I remember him crawling underneath his console and giving me 3 feeds out the back into my little mixer, and I broadcast that on the radio station. And then after the concert, we put all our equipment away and struck everything, and Bob said, you want to go have dinner? I said, sure, let's go have dinner. And at that point I told him, well, I'm not really in college anymore. And Bob says, well, come work for me. And the rest is history.
The world of communications changed because of you joining.
It's never been the same.
And Bob is one of 3 people that I know who've known Pete longer than me.
Exactly.
It's Bob Tourkow, Lou Shapiro, and Roger J. Those are the 3 I know who've known Pete longer than me.
There we go. So, Audio Plumber, you want to give your quick little spiel?
Oh, the Q&A announcement? Why, sure. Yeah. Many of you here have heard this many times. But this is very Q&A driven. These practical show tech webinars, we thrive on Q&A. So in your GoToWebinar control panel, there is a tab that says questions. That's where you can enter your questions. As I hope you know by now, please be specific in your questions because they will be answered not at that moment, and they will be completely out of context if you're not specific. So ask questions, make comments, be specific, learn something new. That's all I got to say. Or
Fair
learn
enough.
something old.
Something old. Exactly. Exactly.
Well, that's why Pete invited me, right?
Exactly. Exactly. Bob is the only comm person I know who is older than me, only by a couple of years. So he's my mentor. But however, I started comm quite a bit earlier than I ever met Bob, and it started in my backyard. I was doing a show with nobody, but my neighborhood friend and I decided we needed to be able to talk between our houses. So I knew about one wire dry intercom as opposed to 2-wire and 4-wire. And so we took 2 tin cans and stretched a little steel cable in between them, and they were like big number 10 cans. And it worked perfectly. It was absolutely flawless audio on each end. And we would sit there at nighttime talking between our 2 houses. It was great. It was great. And then it worked fine until somebody decided to start hanging laundry on our comm line, and it sort of stopped. But that was my first introduction to comm.
Did that make it a wet intercom when they hung the laundry on it?
When the laundry was on it, it became a wet intercom. Exactly, wet and dry in comm's parlance means if it's wet, it's got DC travels along with your comm, and if it's dry, it's just audio. So this was an intercom system that Lou Shapiro, when I was in a company with him, Erskine Shapiro Theater Technology Incorporated, we had used the only thing we knew about comm at that time was telco headsets, 52 BW headsets, which is what operators used to wear. And we bought a ton of these, and we found Lou found a rubber, a foam pad for it, so you could sort of wear it on your head without your ear falling off for an hour. And we plugged them all together, and we wired them together by wiring the headset plus and the mic minus together as the center of the 2, and putting ground on one side of the headset and plus 5 volts from a little power supply using an LMR 365 or 320, some little chip that did beautiful 5 volts. And it was very simple power supply. It just had a rectifier, the LMR chip, and a 2000 microfarad capacitor on the output to make the 5 volt DC totally a short to ground. And we just fed this to the through, and the audio we picked off in between the 2, right in between the headset and the mic, we put on the 3rd wire, and that went to other headsets. Now, carbon mics have a really high level. If you put DC on them, they put out almost minus 10 dB audio. So it was a pretty strong signal without an amplifier in it. No amplifiers involved. But we could only get about 6 or 7 headsets on the system before it became
Before the volume dropped to the point
before
you
the
couldn't
volume
use it.
dropped. But we thought we'd try something just as a lark. We took a Bogan 10-watt amplifier and wired the output and the input together, but we wired the output and the input together through a transformer out of phase. So the amp would amplify the signal on the line, as you see it here. It would go in out on the out of phase side of the amp and be put right back on the same line. And we found we could turn that up and get at least 10 dB more gain on that line, which meant we could run our headsets up to about 20 before it was unusable. But it was only usable for things like a play or a small industrial show. You'd never hear over a rock and roll concert. It was not really very good at all. By that time, yeah.
Did you ever have this system long enough that you ran into the situation that slowly over time the carbon microphones sort of deteriorate in quality? And
let me fix my mic here. There, it's better now.
you have to pound on the mic so it redistributes the carbon granules in there.
Exactly. It was sort of an old-fashioned way. Kenneth Goodwin says Pete's Handbook of Intercom Systems is literally only reading material. Well, it's not my handbook. I had nothing to do with it at all. But I'm going to show it to you. And that reminds me, in the handouts section of the GoToWebinar, there are 5 handouts. I have a handout for on the kind of power supply needed for the RTS thing. It's called Power Impedance. I have a saga of RTS systems, which is the story about how RTS got started. I have the actual handbook of Intercom, which was written by a bunch of people who started RTS, and a couple of pictures of some special usage things, a jib kit, which we'll talk about, and a no hybrid 4-wire comm system. So that's in the handouts. So back to where we were. So this book that I'm talking about is I guess it's at the end of the session. I'll show it to you. This is a list of the comm companies that were around recently, and Clear-Com and RTS were really the two that I was the most familiar with. Clear-Com started in the early 70s, and RTS probably mid 70s got started. Now Clear-Com was started by Bob Cohen and
Charlie Buttons.
Charlie Buttons. And Charlie Buttons is an engineer who was recently honored by having his picture on a Clear-Com belt pack, and he has done a couple of interviews with Steve Savanu, and we're going to be playing a couple of those. This is Charlie Buttons. That's a picture from the belt pack. So this is a recording of about a 20-minute interview with Charlie Buttons, where he describes the entire process of the technology behind the belt pack.
The evolution of Clear-Com. Well, back in the early days, Bob and I were each in the rock and roll sound rental business. Of course, neither one of us had a really big system because
he's talking about Bob Cohen, not Bob Tourkow.
Neither one of us had all that much money, but we were mutual competitors. Bob had Bob Cohen Sound over on 759 Harrison, and I had Button Sound over on Evans Street. So as we were doing these rock and roll gigs, which kept getting bigger and bigger and more so, it became necessary to send runners through the audience with a note to the people backstage, which was becoming harder and harder to do as the crowds were getting bigger and bigger. So one day, I had been working on some kind of an intercom system to go between the stage and the mix console, and unfortunately, none of them were very successful. And Bob came over one day and he goes, "You know what I've been thinking about? I staged a mix console sound system." So then Bob pulled out a little notebook and he said, "Okay, what does it have to be?" Well, it has to work on mic cable because that's what we got. And it has to be small and portable, and it should have a call light so that you can call the person to come over and pick up the headset and talk to you. Okay. Then we're talking about the basic system. Well, at that time, the only system that I had seen used at all was the Terry Hanley system out in Boston. And Terry did use a headset with a boom mic, and it went down to a belt pack. Now, the belt pack in Terry's case was simply a junction box, but the concept of a belt pack was there. And then in the Terry Hanley system, it went with a giant cable off to an amplifier in the back room. The amplifier amplified all the signals and then sent them back to the headset. So it was kind of a clunky system with a rather large cable and an 8-pin Canon P connector, but it was a system of communicating. So I'm thinking about this going, okay, first thing I got to do is come up with a headset with a boom mic. So I happen to be downtown. San Francisco Radio was extolling the Switchcraft Language Laboratory. And I looked, and the one thing a language laboratory had was a dynamic headset with a dynamic noise canceling boom microphone. So I immediately bought 2 of these brown things. They were expensive. That was about all I could afford, is 2 of them. Brought them back to the shop and then proceeded to look at what the parameters of these were. Well, the microphone signal that came off of them was very small. And I said, this mic signal is not good for going much of anywhere. So I had been fiddling with IC amplifiers at that time. And I said, wait a minute, I can put the IC preamplifier right in the belt pack. So that was the first step, is to get that in the belt pack. And I said, okay, what else? And I'm going back and forth. And about that time, Philips Amprex sent me the literature on their little audio power amplifiers. And I'm going, wait a minute, I can put the receive amplifier in the belt pack too. And that means you have a real volume control. So finally, working with that, I suddenly realized I take one conductor and put the power on it to power all of the ICs. And then the audio preamp would feed the line, and the amplifier for the earphone would be in the belt pack and would take the signal off the line and put it into the earpiece. Well, obviously, you can't run more than one amplifier on a line without them interfering with each other. So you have to put in a series buffer resistor. Okay, so I did that. Now it turns out each time you double the number of belt packs, you go down 6 dB. And I'm going, how do I beat this dragon? So then finally I said, wait a minute. If I terminate the line with a fairly low impedance resistor and then feed the line from the preamps with a higher impedance resistor, that way the signal won't go down quite as fast as you add belt packs. Okay. So then I go, well, what should the impedance be? So I spent quite some time figuring out wire resistance loss, going back to a termination, versus the wire capacitance, which would roll off the high end. And so I went back and forth with that until I finally settled on 200 ohms for the termination. So at that point, okay, if the amplifier feeds the line to 3.9 k ohm, and you've got a 200 ohm termination, now you don't go 6 dB down until you reach 20 belt packs. Well, in talking with Bob, Bob says, well, of course, nobody would ever use more than 20 belt packs. It'd be total chaos. Nobody would ever do that. Oh, okay. What about the call light? Oh, yeah, the call light. So then I said, well, wait a minute. If I feed some DC onto that line and bring its voltage up, I can use that to activate the call light. Well, with a 200 ohm resistor, it's kind of a heavy load. So then I said, wait a minute, I'll put in a 10 microfarad capacitor in series with it, so it'll look like 200 ohms for audio. And then I'll shunt the capacitor with 4.7 K, and so it'll look like 5,000 ohms for DC. So by doing that, that allowed me to put current on the line at first through a resistor, which created a hell of a thump, by the way, and activate a call light. So that was how the call light evolved. And at that point, on 2 large vector pegboards, I had constructed 2, quote, belt packs, although I had bought the parts from Zach's and they were huge. You know, genuine TV service parts, Blue Beaver caps, and such all things like that. But it was 2 working belt packs that would talk back and forth through a mic line. So then the next thing would be, well, boy, there's not very much power to the earpiece from these little IC amplifiers. The best I can do is about 50 milliwatts, maybe a little bit more. So what do I do about that? So at that point, Bob had bought the very first 3rd octave equalizer that any of us had really seen, which was the Altec Acoustic Voice set. So I managed to wrangle that off of Bob, set my sound system up in the shop, and went from my mic preamp through the acoustic voice set to my earphone amplifier and said, let's see what I can get. And very quickly I discovered that the lows use up all of the power of the op amps, crash them into the rails, and contribute very little to the intelligibility. So it very quickly became apparent to attenuate the lows, move those down. Now the highs used up a whole lot less energy. And in the human voice, above 1,000 cycles, the energy goes down anyway. So I can push that up and use that. And with the acoustic isolation of the earpieces, I could hear that come through and it was intelligible. The first frequency response curve I evolved with this method was really very bright. You wouldn't recognize your own mother through it, but it was crisp and sharp and you could understand it through all of the background noise. So then we had to kind of consumerize the curve a little bit to make it much more palatable, I guess you might say. And we're sitting there going, okay, what do we call it? Well, we could call it Comm, or, well, we could call it Clear-Com. And finally, as we went back and forth with names, Bob says, well, Clear-Com sounds pretty good. We'll use that for now. We can always change it later. Okay, so we did that. So then Bob went over to Mike Quinch, which was a surplus house over in Oakland, and bought all of the little parts and proceeded to lay out a bell pack sized circuit board using these little parts. Carolyn made the circuit board in the bathroom and we proceeded to solder some together. Now, since the connector on the switchcraft headsets was the wrong weird thing, we had to cut it off. Originally, we used tip ring sleeve plugs, tip for microphone, ring for earpiece, and the sleeve was the common ground for the 2. And at that point, Bob bent up the sheet metal, and we made the very first Clear-Com bell packs. Well, it was, everybody thought, gee, that's really bright. Everybody said, well, my bell says you only need 3,000 cycles for communication. And I went, yeah, but my bell isn't involved in rock and roll. But people started using it, realizing that, yes, in a rock concert, they could hear and understand the voice. That was a really, really big deal. So at that point, it really started to go into wide use. Now, some of the things we realized early on in my testing with the large sound system in the warehouse was simply this. When you're in rock concert, you naturally tend to shout or talk very, very loud, which is good. If you put the mic up close and have the microphone gain down, you can get rid of the background noise. And that gives you a good voice versus noise ratio. So in this case, microphone gain more is not better. In fact, for concert, you use less because you need to have the microphone right up close and you need to talk loud and be over the noise of the band. So that was one of the things we realized early on. You do not want too much low end because it just sucks up lots of power and adds virtually nothing to intelligibility. You do want a lot of soup in the high end because in concert, you hear the rumble of everything come through the earpiece because they don't have that much mass. But the ceiling is good enough that the high end is well attenuated and you can hear the crispness, clarity of the voice pop through that background noise. So you can still understand the voice in spite of the very high noise level. So at that point, it began to take off, and we started manufacturing belt packs with this system. Well, first thing of all, we finally discovered the phone plug wasn't doing it for us. The coupling between the earpiece and the microphone was too close. They would have a tendency to oscillate sometimes. The frequency response was weird. And that's when we had to change to the 4-pin Canon so we could have much more isolation between the microphone and the earpiece. Originally, we used 1 for mic ground, 2 for mic hot, 3 for earphone hot, 4 for ground. Later on, we discovered we did not want to put those 2 conductors close together, so we flipped the earpiece so it goes now mic ground, mic hot, earphone ground, earphone hot. And that's the system we're still currently using today. We're still using the 200 ohm termination because you have to have everything compatible. Unfortunately, at the time, Bob wanted to be very careful of how loud our line levels were because he didn't want it to interfere with his microphones when he put it through his mixed console to stage snake. Well, if we had known, I would have had the line level considerably higher than it is, but too late now. We can't change it without obsoleting everything. So that became fairly popular. And then one day, Bob got a phone call from a guy who goes, you know, when you use a lot of belt packs on the line, the level gets really low.
That probably was Larry Estrin calling, and he was working with Bob Tourkow, and this Bob Tourkow was the one doing comms on this show.
And Bob says, well, how many are you using? The guy says, 130. Bob almost dropped the phone. We didn't even realize we had made 130 at that time. What are you doing? Oh, I'm doing the Academy Awards. Oh. So at that point, we had to give up our 3.9K resistors sourcing the line and change over to a much higher impedance structure for that. But that was the basic evolution of the belt pack. And the things that we come away with on that is simply this. First of all, mic gain. More is not better. You want it down to the point of where you gotta really talk up into the mic good and loud to be heard. And that dumps the sound of the orchestra. We did later on put in a microphone limiter, and what we very quickly learned is to put the level of that limiter well above the voice. It is merely to prevent the mic preamp from clipping if somebody really shouts. But in normal operation, it is not active. And again, because what happens is you'll hear in sports broadcasts, what they'll do is put everything down into the limiter so that it pumps up the background noise whenever the announcer is not talking. And it sounds like the audience is tearing apart the stadium. Well, for communication system, you don't want that. You don't want it pumping up the background noise. So the limiter wants to be well above the voice level. Earphone levels, it's quickly realized by all of us that if you're sitting in concert at about 115 dB SPL, the human ear itself physically distorts. You can be sitting next to somebody, they can try shouting at you. You hear them, but you can't understand it because of the distortion. At that point, your ears are physically distorting, and also you're beginning to suffer permanent hearing damage. The level wants to be below 115 because that's the onset of distortion and also the onset of very quick permanent hearing damage. So therefore, the concentration must be on signal over noise, which means the earpieces have to have good, solid, coherent structure, nice, big, fat, well-sealing ear cushions to attenuate that background noise as much as possible, so then you can hear over it. The other thing is when you actually get in concert, you want all of the mics to be off, basically, unless somebody needs to speak. So therefore, you go to a push-to-talk operation where a person turns on this mic, says what he wants, turns it off. Fewer mics on, less background noise in the system, because once you get noise in the system, you cannot get rid of it. Now, some people have had success with putting ear defenders, or essentially earplugs, but good ones that let the high end through, in their ears and then putting the headphones on. And that way, the ear defenders will attenuate everything by, say, about 15 dBs, including the leakage sound around the earpieces. And so you can get the voice up above it. Unfortunately, that's very uncomfortable for people, and many of them are not likely to do that. So it's better to have headphones that really do cut out the background noise. And that's very, very important. All you got to do is look and see what the airplane pilots and the tank drivers are wearing, and you'll see this. Small and cute does not work. One of the other things that we found very much so, and is still true today, that the thing to do is to have, say, like a room in the middle of the house where you can close all the doors so the neighbors don't scream, or wait until the neighbors are away. Crank up the sound and so you get about a 95 dB SPL sound field in the room, and then try your communication system. At that point, it will become very clear what works and what does not work. And so it's always good to do that. It's kind of like going through combat training before you're under fire. And it's a very excellent way of telling what does and what does not. Let's see. I think that does it for now. So I will end this.
Absolutely great recording from Steve Savanu. We have another one we'll share later where he talks about how they invented the King Biscuit. But Kevin Parrish remembers Zach Electronics in San Francisco. Great. He said there was a very young Kevin Parrish there. He got parts for any early projects, learning and repairs. And he also says this was in days of Swanson Sound, early introductions of PA systems. But also Kenneth Goodwin says Charlie Buttons retired before all his deaf stage managers in theaters started whispering into their headsets and complaining they couldn't hear each other on comm. Hence the invention of digital comm. So, Bob, you had a couple of comments on this drawing here.
Yes. This was fascinating. I worked for Clear-Com and Clear-Com. I'm sorry, my mind is going. I did not work for Clear-Com originally, but Larry Estrin, when we were putting together Best Audio and before that Filmways Audio Services, I dealt with Clear-Com a lot and went to their facility in San Francisco. And there have been comments that Clear-Com sort of comes out of the rock and roll music business, concert business. Well, There's another word that frequently goes along with that, and it's hippies. And so sure, I'll tell it. One of the things when I went into the Clear-Com facility, which was very interesting, like an old barn type thing, and they built a second level on it, and it's just Friday afternoon there was a pot break. They would smoke grass, and the dealers, when they were selling them, they knew they should try and not get product that was built or completed on Friday. Not a good thing. And it was just a very quirky thing. Before I tell the thing about the 200 ohms, go back to the list of people, companies. One more. Okay. Chaos and Goddard Design. I don't know if you know this, Pete, but basically that was virtually like Clear-Com with one exception. He didn't feel Clear-Com was loud enough, and Clear-Com's volume was limited by the maximum voltage on the rails, which was 30 volts DC. So Chaos, he put his system up to 50 volts so he could get a much louder earphone amplifier. Right? Did you know that, Pete?
No, didn't know that. But I know that you don't want to plug a chaos line into your intercom system.
That is very true because they are compatible. Go back to the circuit. The 200 ohms is a critical thing, and for those of you who work with two-wire intercom or powered or wet intercom, you know that termination is critical to how the system works. And as Charlie explained, and I don't know how many people followed it, but the high impedance that the belt pack presented to the line to the terminating resistor was the critical thing that really made the whole thing work. You could put on the belt packs, and the 200 ohm resistor basically determined what the level was on the line. Now, Clear-Com did say that, well, some people might want to use 8 belt packs, but some people might want to use 20. And by the time you got to 20, your level on the line started to drop because even though the belt packs were a high impedance, they started to load down the line. So Clear-Com power supplies, many of them, in place of the 200 ohm resistor, Pete, I'm thinking, gee, how can I circle the 200 ohm resistor here? That 200 ohm resistor, it wasn't a 200 ohm resistor, it was a 1K pot. Because if you wanted it to get louder, you put in more resistance, and then the current driving of the amplifiers could operate louder. So one of the biggest problems that you run into with Clear-Com is you plug a system together, and I'd be interested in how many people run into this. And it's all distorted, and it's so loud, and nobody can understand it. And you're trying to figure out what the hell is wrong because I've connected it. And inevitably, yeah, you've run into that, Jack and Pete. Yes, I'm curious. So let me know if anybody else sends in that they have run into it. It has to do with there's no termination resistor. And this actually is true of RTS also, that if you ever get on a two-wire party line, RTS or Clear-Com, and it's totally distorted and very, very loud, it's because there's no termination in the system. And because systems got more complex, that could mean that a termination switch is turned off. So that's just a little, and I'll bet a bunch of you, most of you out there that have dealt with this have been aware of the importance of termination.
Oh, yeah.
Also, it wasn't mentioned, but in Pete's drawing on the belt pack, you see a little yellow box marked anti-side tone. Well, there are two things about side tone. One, if you're talking on your mic and it's putting your voice signal onto the line and being heard by everyone else, it is a certain gain structure. But also, because your earphone is on that same line, you'll be hearing yourself. And if you hear yourself too loud, it makes it difficult to communicate. Also, if you happen to be located near a speaker stack and turn on your microphone, you almost can't hear what's going on because you're getting so much signal from your microphone back into your earphone. So both Clear-Com and RTS in two-wire systems have got a circuit that takes some of the microphone signal, flips the phase, sends it back into the headphone, and that's called anti-side tone, or it's called side tone, either way. In a totally perfectly terminated system, actually you can adjust the control, the side tone or anti-side tone control, where you virtually don't hear yourself at all. And you don't want that. And Clear-Com settled on having, they feel that the side tone should be 6 dB down, so you should hear yourself 6 dB lower. And the whole thing about side tone is that, like in the telco system and in your normal phone line, side tone is sort of built
Talking about in a plain old telephone line, not a cell phone.
Right, plain old telephone line. Because when cell phones first came out, we all experienced, both in our own actions and in other people, that people are on that cell phone and they're talking so loud, you can't understand why they're talking so loud and they're bothering everybody around them and so loud. It's because in a pure four-wire system with totally independent listen and talk, and that's what cell phone is, you don't have any side tone. And if you don't hear yourself from a psychoacoustic standpoint, you don't really believe you're being heard. So you get louder and louder and louder. And I'm almost certain that current cell phone technology doesn't put side tone back in.
No, not at all. Not at all.
We've just gotten used to it. And this whole thing about side tone in two-wire stuff, the digital stuff has given us total echo canceling, or we shut off side tone totally.
European comm systems don't use side tone. They typically like it off all the time. And American comm systems, and I'm talking about digital and analog, have side tone. One of the biggest advantages of side tone is you're listening to your mic, and if you turn your mic off, you don't hear your side tone, so you know your mic's not on. So it's, you don't, on a comm system, you never have anybody say your mic's muted, because it's not a web conference, it's an intercom, silly. You know when your mic's off by listening to the side tone. So that's,
by the way, you mentioned Europe. I just wanted to mention, actually, I'm
what did you say, Matt? Your mic's off. Yeah, your mic's off.
Oh, right.
Yeah, I mentioned Europe. What?
I just wanted to mention that I'm in England now.
You look like you're in England.
Really? Uh-huh.
Yeah, you look very, very right. You're way on the right-hand side of my screen, which is closer to England.
I see. I just have to tell you a tiny little thing. One of the things that drives me crazy compared to living in California or even New York, which I've spent most of my life, is that, God, I never can remember. London, England, UK is on a much higher latitude, much higher than you guys are. And in the summer, we have like 18 hours of daylight. And it doesn't start to get dark outside until about 10 o'clock at night. And the sun comes up like at 4 in the morning. And it's just really, really strange.
And how does that affect your comm system?
I find, well, the comm systems that the comm systems that develop that quirky problem that's really hard to trace down, where the the time waiting to sunset actually starts affecting the gain of the system.
Got it. Got
But
it.
that's very rare that happens.
Uh, I don't have his name yet who said this, but the reason for the no side tone on the cell phone is that the ear is not covered from the headset, so you hear yourself fully acoustically. In reality, the reason there's no side tone on cell phones is they didn't want to have to deal with it. It was an extra electronics they had to put in, and they decided it is not really necessary. Now, if you talk on a plain old telephone, POTS line, you hear yourself in the headset. And it bothered me for years after I got a cell phone that I couldn't hear myself, and still wish that they would add side tone back in for the situation to prevent people from yelling at each other. This is a typical Clear-Com bell pack, brand new kind of version. It's shown on one of the little stands they also make if you want to set it on the table. And if you notice on the left-hand side where it says Intercom, that's an in and an out. They're basically paralleled. So you can plug from your power supply into the first belt pack, jump to the second, third, fourth, fifth, sixth, seventh. But I always avoid doing that because what if the first guy decides to move his belt pack to a different place on the table and he unplugs it? Bang, you've unplugged the entire production table. So the thing to use on those is some kind of splitter. And the nice things about two-wire intercom, they can use a passive splitter. You can have an XLR-Y cable and just split it into two bell packs, or on the Telex TW5 is 1 in, 5 out box. And down here from Audio Specialties is a 1 in, 11 out, 6 on one side, 5 on the other side, which is nice. It also has built into it an LED monitor, so you can verify that its power is right in there. But that way you can run one cable to a table and run out 5 cables to the belt packs on the table. And I always
don't some of them have 2 lights? Because
yeah, I just noticed this particular one only has 1, but yeah, some of them have 2 lights, and it's in larger RTS systems. I like to put power on every single channel because you never know where you're going to plug it in. Now, RTS belt packs we're looking at right here, they get their power from pin 2, same as Clear-Com. So here's pin 2 in an RTS belt pack. It has 30 volt DC. It has a special kind of power supply, current supply, which is basically not a short to audio. So in other words, audio can be mixed in with that DC. And so that's how they get 2 channels of intercom on there. So here we've got the A channel on the channel that has the 30 volt DC and a termination. And here we have the third channel, which has the B channel with also a termination, and there's no DC on this. But if I'm doing a big system, I don't know where I'm plugging these things. So I've always got to have power on the A channel, or my belt pack's not going to work. Now, on a huge system, you could have enough belt packs to tax the power capability of your power supply. So what I would recommend is put your most common channel, let's say production, on the B channel. It's not a powered channel. It's not going to suck any power of any power supply. Every single belt pack has your production channel, and the secondary channel, like maybe the Stage Manager ISO channel or the Audio A2 channel, is on your A channel. And that's counterintuitive. People always guaranteed put the production on A, channel 1, and the other on B. That means every single belt pack in your system is going to be powered off of one power supply. But this is basically the same as a Clear-Com, except they added another channel to it. And I've drawn it feeding 2 ears of a 2-eared headset, which that's a capability it does have, which you can't have with Clear-Com, because Clear-Com is only a single channel in their basic belt pack. Clear-Com now makes, for years now, it makes a TW belt pack, which is basically the same as the RTS bell pack. And in fact, some of the newer bell packs actually have a switch, so you can switch between Clear-Com 2-channel and RTS 2-channel, because the main difference is level.
Right.
RTS
Different
runs at
operating
0 dB and Clear-Com runs at minus 10 dB. So that's the main difference. So
Do you know why that choice was made?
because Cohen did not want to have line level audio mixed into his multi with all
Yeah.
the mic level.
Right.
And so they lowered it. But in reality, we've never had an issue running RTS, which is a good hot 0 dB on a multi with it. And now with digital, who cares? So
Right.
you'll never have
What's
common
multi? What's
digital
that?
anyway. Exactly. What's a multi? So this particular bell pack looks like this inside. And this bell pack, I don't have a real date on it, but when do you think this bell pack came out, was originally invented, Bob? In the mid 80s?
I, perhaps, it's awful. I don't have a timeline because actually, I have been actually an employee of Clear-Com and an employee of RTS, and I was with RTS when we designed this one. And boy, the fights that went on internally, where people like me who had worked in the field, we said, "Oh, let's put in this option. Let's put in this option." And there were other people in RTS that said, "Why would you want that? Nobody's going to use that. People won't understand it." It was a real fight, but this was an amazing belt pack. I think it is Pete Erskine's favorite belt pack in the world other than digital.
Well, it still is viable today and has so many options you can do with it that it can do so much stuff. I want to make a couple of comments here. I'm back on side tone. William Pyle says latency is an issue as well if you're creating your side tone back at the central office with a cell phone. So digital intercom systems create their side tone inside the bell pack, and they don't do the round trip to your computer who's running it, which is fine. It allows you to turn on your mic and hear your voice, and that allows that to happen. But it also, unlike an intercom system, or you can't really tell anything about the rest of the system because you're hearing the side tone. It's done directly in there. And then John Center says termination was always a major issue on Broadway, where you have so many different channels running, and often some channel would be really hot, and it would be because it wasn't terminated. Now this particular belt pack that we're looking at right now on an RTS system uses a power supply, and I'll show you a picture of the power supply a little bit later, which on the back of the unit, it has a switch. It says 200 ohms, 400 ohms. And the reason for that is not a level control switch. It's because the power supply, named PS31, was originally designed to power 31 of these belt packs. And if you wanted to have more than that, you could parallel another power supply on it. But if you parallel the power supply, you parallel two 200 ohm terminations, and you want to be able to fix it, and ended up too loud. And so you now switch the two power supplies to 400, which sum together become 200. Now Clear-Com deals with that in a similar way, except they just have termination on off on every channel. So if you plug two different power sides together, you turn on the termination on one, not on the other. Some electronic equipment connected to digital intercoms, where you're connecting a 2-wire circuit into the digital intercom, we'll talk about this later on Thursday, would go into feedback if the line was not terminated. So what they did is they actually powered that device from the intercom line. So unless the intercom line was live, the device wouldn't come on and you wouldn't get feedback. So in this particular belt pack here, this is a drawing of basically the same thing you see on the left here which is inside the belt pack. This is a slightly larger drawing here. So here you can select your headset settings, and the belt pack has you can feed a program feed into it, into the actual physical belt pack. You can feed it to either your left ear or your right ear, and then you can feed the intercom channel listen on either on or off, the channel 1, channel 2, and then you can make the belt pack mono or stereo, and stereo would be with the 2. So I could have a headset where channel 1 fed here, channel 2 fed here. On the bottom of the belt pack was a 1/4-inch tip ring sleeve headset connector, and that plugs in right here, and that can be 2 different things: a carbon mic headset, like this headset right here. People still like to use these. They were used to them. Theron Musser used this kind of headset until the mid 80s, but by then they were plugging them into modern belt packs. But she liked the feel and use of that headset, and that had a different level control and needed DC in it, and so that you plugged it into the 1/4-inch and put the little jack. So if you look in this drawing of the box, all of these XLRs come out with pigtails on them, and they're plugged into certain places on this in this PC board. And depending on where you plug them in, they did different things. So if I wanted the mic to be a external mic switch on, where I pushed a button to turn the mic on, I could use that 1/4-inch jack if I moved the jack over here. Then over on the right-hand side, I have a place to plug in the mono 4-pin headset, the stereo 5-pin headset, and input audio in. That's where you would feed your program audio into the belt pack. And then the 2 bottom ones here, rather, I take that back. There's intercom input is this one, and next to it is the intercom loop, which is the male and the female cables. But I could take the intercom loop, instead of plugging it into here, I could plug it into the jack right below it, which is program input. Oh, went backwards too far. There, program input. Then I can get audio in there. And then right above that is remote mic switch local power. So one of the uses of this belt pack, which I'll show you in a few minutes, is I need to power the belt pack directly where it's sitting. So I can take a 30-volt wall wart and plug it into the 4-pin XLR and move that jack over to remote mic switch local power and power the belt pack. These 2 labeled buttons, these knobs labeled balance 2 and balance 1, are the anti-side tone controls. So you can set the side tone on either one or the other. And you can adjust them so that there's virtually no side tone. And there are certain situations where I have used this belt pack as a hybrid to actually separate the audio in the intercom into a send and receive, which makes it a 4-wire. And in those cases, I don't want the input of the belt pack, in other words, the mic in, to get any audio from the headset out. So I null it so that the mic going into the headset is virtually off. And then there's a little dip switch thing here, which allows you to turn on and off the call signal capability, to make the buttons momentary. You can disable the talk on channel 1 and channel 2. You can, and then the other thing you can do is you can set the belt pack. It says talk off transmit enable and talk off receive enable. If you have the talk off receive enabled, you can, on the outside of the belt pack, press 3 times the call light, and it will light up for 1 second. And during the time that it's lit up, you can press the talk channel and it will turn off everybody's microphone on the whole system.
Everybody's microphone on that channel. You have to enable talk. You have to enable talk on one of the 2 channels. Then you go through that process and it turns off all the mics on that channel that have talk off and receive enabled.
Exactly. So normal setting I always like to have is momentary on both channels and talk off receive enabled. And I usually try to set up all the belt packs this way, and under annoying protest will make them latchable. So you can't always have what you want, they say in the comm business, but you can if you're the comms person. So talking about being the comms person, this is a book which is in your handouts, by the way, written by a bunch of people worked in telex. And who are they, Tom? Who are they, Bob?
Well, who did the manual?
Who did the manual?
Well, Stan Hubler, of course, was a big one, but there were many people from telex that did this. They pulled
Right.
in information from RTS, but I don't remember all the people that actually contributed to it. But it was a labor of love. The guys who put this together really felt there was nothing that clearly explained intercom systems, and I think this is a beautiful thing. And you know, I read it daily on the toilet.
Yeah, this is a book that I recommend.
Right next to the Sears catalog.
No, it's a very good. It's an excellent book.
This is the book that somebody mistakenly attributed to me, and I am very honored by that misattribution. But this is the book I recommend that people read if they're about to learn about comms, because it really goes from your basic two-wire comm system all the way up to digital matrix systems. Covers it all. Great references in the back and glossary and all kinds of stuff. Kevin Parrish says the date code on the label is 1992. That's he's talking about the belt pack on the RTS. This deck, this PowerPoint deck, of course, will be in the download section. It's not going to obviously in the handout section now because I am madly editing it as I'm talking to you, but it will be available on there. So this is a book you want to read if you want to learn about comms. Now this is something that I want to have Charlie Buttons talk about for about 4 minutes.
One of the early shows, we were setting up. Bob says, "I've got a surprise for you." Oh, what's that? He says, "Look at this," and he opens up a box and pulls out a little wooden wall baffle with like a 5-inch speaker in it. And in the top, he has a volume control, a call button with a call light. Out of the right side came a curly cord with a little push-to-talk handheld mic. He sets it up on the stage, and we go, "What's that?" He says, "I call it the King Biscuit. Look at this. You can plug the Clear-Com into it and talk out through the speaker to the people on the stage. And if they want to talk back, they can come over and pick up the mic and talk back." And he even had it labeled King Biscuit 100. And we looked at this going, "Oh, huh." Well, it turned out that turned out to be a very popular unit. And then about that time, we also discovered the principle of anti-side tone. That is, being able to take a model of the actual path going onto the line and off of the line, creating the same thing artificially, and then putting the two together out of phase so that we could remove the direct microphone to speaker path. And this is what's called anti-side tone, because hearing yourself with side tone, so removing it is anti-side tone. Down at the original building on 759 Harrison, as people would come in through the front doors, which were just plain wooden garage doors and not especially quiet, we set it up along the wall with the microphone good distance away from the speaker, so as people came through the doors, we would hear them and we could talk to them through the speaker. And that was essentially a hands-free station, which was very, very useful. And that, of course, is when we discovered You can do that and create a hands-free station at one location, but you can't do it twice. And it took us a long time to figure out that if you tried to do it twice, what would happen is the sound would go from the microphone of the one station out the speaker of the other, back in the microphone of the other one, back out the speaker of yours. So you could do it once, but you couldn't do it twice. So we had that one station set up downstairs next to the garage doors, and as people would come in, we'd go, "Who's there?" and talk to them before they came up the stairs. Well, needless to say, that was our first speaker system, the King Biscuit 100. I think Bob named it after the King Biscuit Flower Power Hour, which is a radio show that probably most of you don't remember. But it proved to be an extremely popular station. But as a matter of fact, Ed Fitzgerald still has one of the original wooden ones on his desk. I know one opera company has got a whole group of them strung across the fly rail so that people up there can hear what's going on and they can go over and pick up a mic and talk back. And chances are by now those stations are older than most of the people that are there. That was the beginning of the King Biscuit, and that's where we got KB from.
So Steve Savagna says his Performance Arts Center still has a few of those on there, and it definitely was a strange name, King Biscuit. I remember the King Biscuit Flat Power Hour. It was a musical show, and it was sponsored by the King Biscuit Flour Company, and that's where it got that name. So it worked for me. I don't know. This is one of the current models of it, the KB702 wall mount version, and the wall mount version can also be mounted into a desktop thing. And on this particular one, allows you to turn the speaker on and off. You can do a separate program level in. It basically has a KB325 belt pack built inside of it. So it's sort of the same things available. Volume of the speaker, call light, talk button, and the side tone control. And either you plug in a headset or a gooseneck mic right here, or a little short stubby mic. The normal SPK 300 Biscuit, which is an RTS unit, has two channels, just like RTS does. It's got a mic on off, a speaker on off, and here it has a side tone control on the front. And the adjustment of the anti-side tone is really important, because when you push the push-to-talk mic, if it's not adjusted right, you get a lot of feedback, because you've got a lot of gain going into this speaker right here. So you want to sort of annoy the entire comms channel by pressing the button, making feedback, and adjusting the side tone until it goes away. And everybody screams and yells and hates it. So try to do it before everybody gets on comm. Now, the interesting thing is this side tone control, this anti-side control, is only for channel 1. There is an unlabeled hole on the bottom of the box that adjusts the anti-side tone for channel 2. So you have to sort of look in the 2 or 3 holes that are in the bottom of the box, find the one that has a knob in it, and do your adjustment there for channel 2. Next. This, in RTS, you've got 2 channels. Channel A, which is on pin 2, and channel B, which is on pin 3. Well, if you just ran a line out to, let's say, a TV dolly, and at that dolly, you wanted to have a headset for the camera operator and a headset for the grip who's pushing the dolly, you can put one of these adapters in line. Female is the input coming from the power supply. Incidentally, strangely enough, all intercom power supplies come out male, because I guess they didn't want people plugging microphones into them. And so it's reversed. So you're always having to have turnarounds to make the multi work for you. But this unit basically disconnects pin 3 from the power supply, which would be your B channel, and puts a termination right there. So now all the belt packs plugged in the male end right here will hear channel B, because it's powered on 2, and 3 is just an audio channel. They'll hear channel B and they can talk amongst themselves, and it's isolated. An aside, because channel B is on 3, which is Clear-Com's normal channel A, if you plug a Clear-Com belt pack into an RTS line, which is okay, it will work, but it'll come out the B channel in the RTS system.
And the levels will be different.
And the levels will be different, but 10 what's 10 dB between friends, you know?
Right.
Exactly. Now, years ago, I was working on a show in Nashville, and I was using a TV truck that had an Atom system in it and an RTS system. And there was no external system. I didn't have any system inside the venue. I just had a bunch of BTRs. And they ran the wet audio, wet being two wire audio that has power on it, into me on a DT12 multi. And I would plug in all my belt packs in there, and then I'd plug in the BTRs. Well, the BTRs were on separate power. They were on the power inside the venue, which caused all kinds of terrible buzz. And you could get rid of most of the buzz, but not all of it, by lifting the ground on the BTR and endangering anybody who touched the BTR and another ground with 110 volts. So I didn't want to do that, but during lunch, I realized that if you took a transformer and transformer isolated separately between pin 1 and the audio channel with a separate transformer, so this one here is on the channel 2 or B channel isolated, and this transformer up here is on the channel 1 channel, I basically have created a transformer isolation. There's no physical electrical connection here, like an IL-19 transformer or an ISO transformer. So I ran out at lunch. I bought 2 Radio Shack transformers and 2 capacitors, which were non-polarized capacitors, because I didn't know whether I was going to be running it one way or the other. Ultimately, I added capacitors to the other end as well, because I didn't know if anybody was going to plug it in backwards. And I plugged it in, and bang, the system was dead silent, hence the name BuzzBuster. So this is also available from a company as a pre-made product called Audioman IsoBox. And if you just Google Audioman IsoBox, you'll find the company. They make a lot of little adapters for intercom, but this was one that was particularly good. I'm going to skip this page because I'm going to tell you that page. This is a use of the the BP325 belt pack as a 4-wire belt pack, which means the talk is on channel 2 and the listen is on channel 1. Okay, so on this belt pack, when I listen to the belt pack, I'm going to be listening on channel 2, which is the channel 2 volume on the left here. And I'm going to be talking by pressing the button on channel 1. That way my audio never connects. The talk and listen are totally separate. And I go into the power supply and I come out one of these audio only adapters, just like I showed you early on, which splits the audio into 2 balanced levels, balanced transformer isolated levels, audio into channel A and audio out from channel B. And I plug this into an audio box that the audio department had dropped in my room, run by fiber, to 36 other rooms. And all those rooms fed all their audio back to the main theater. And there I took these 32 channels of audio. Actually, no, I think I multed them all. It was all in a Dante. So I multed them all together. So all of the different inputs were a feed from my end, and all the different outputs were feeding into one end somehow, but I had only one input into my local Riedel artist. And that way I was able to put all these belt packs everywhere without using any kind of adapter. So this is also useful if you have to run comm an extremely long distance. You can have, even if you're using it as a 2-wire system, if you talk on one channel and listen on the other, there won't be a problem in running really, really, really long cables, like a mile or 2. I've done that on the Olympics, run a mile of cable out, powered it locally at the other end, and just talked on one channel and listened on the other.
Pete?
Yeah.
This might be a good time to mention something that sort of can get lost in the background. I'm sure that everyone who listens to this are not only intercom, but very, very, very familiar with audio. And you know the clear difference between balanced and unbalanced signals.
Right.
And there is no one who has worked on comms that has not at one time or another run into hum, buzz, noise, all sorts of strange problems that are noisy, that you're constantly being bugged. Get rid of that noise. Well, just hold in the back of your mind that part of the reason for the buzz and hum, getting rid of it, is that in audio, we make everything a balanced signal. So when we're running mults, again, before digital, and running all sorts of XLR cables, it's because the signal is a balanced signal, it can reject interference from lighting cables and all sorts of things.
Power cables, whatever. Yeah, yeah.
But these systems we've been talking about are unbalanced. That is, you don't get the advantage of being able to reject noise that's coming in. So it's just something to be aware of, that if you're dealing with it, it's not always that the system is bad or that you've done a bad job or something. There is an inherent noise problem with unbalanced audio signals. And that's one of the reasons RTS chose a higher level, so that they could avoid that more, get a better signal to noise ratio. But it's interesting. And I want to toss out that my whole life pretty much was about this kind of intercom, although the digital matrix. But you guys, I look at the stuff you're using, your digital belt packs, fiber and everything, and it's my belief that your comm systems don't have nearly the hum, buzz, and noise problems that we do.
Back in the 60s, when I first started out in audio, I kept telling people, when this gets to be digital, we won't have to worry about this. That's what I said.
So Pete, just also to interject, your explanation here is about using the belt packs in a sort of a 4-wire mode where you're talking and listening on different channels. This same adapter can be used to make balanced audio, like Bob was saying, so that if you do have a super long run or through a noisy environment, you put one of these adapters at each end of the run, and you can take your unbalanced audio out of the power supply into the audio only box and split it into a talk and a listen path. And then you put another box at the other end, which is a listen and a talk path, and hook it up to another system.
Right.
And locally power it. And then you have that channel balanced audio.
Right.
4-wire.
So this I thought I showed you this one right here. This is an audio only box. So here's your female line coming in, and it's a loop through, so I can plug my intercom in and loop it through to somewhere else. And then there's transformer isolation for each of the 2 intercom channels with capacitors to prevent the DC from blowing the transformers up. So here's line level out for channel 1 or in, it can be input or output. And here's the same for channel 2.
So theoretically, if you use the box like this, you could actually produce convert both RTS and Clear-Com from unbalanced to balanced. And theoretically, that should be real easy to work. But I just want to tell you, in the Atlanta Olympics, we had to put at the end of the kayaking thing or something where, you know, there was miles of water.
Kayaking was your venue.
Pardon?
I did kayaking.
And God, we that was a Keith Hall Intercom Specialties job, but we had to try and balance up the lines, and we had to make underwater splices in the 25 pair telco stuff. And listen, this digital and fiber stuff, you never want to deal with an underwater splice of a 25 pair telco cable.
Yeah. One thing's worth mentioning, in an RTS system, because you have 2 channels of comm in one wire, you're going to get crosstalk between the channels. So there's always a really, really low, usually a really low level of crosstalk of the other channel. However, if you use Canary Star Quad cable with your RTS system, you will have extreme crosstalk, more like 5 dB down, you'll hear the other channel. And that's because it's an unbalanced channel, literally going into a Star Quad cable has 2 wires for each pin. And the 2 wires are wound counterpoise. So one goes one way, one goes the other, which essentially is a transformer. So they're basically inducing in the other channel the unbalanced signal on one line into the other. So never use Canary Star Quad in any comm system, just as a
Or
matter
anyone else's Star Quad.
or anybody else's Star Quad. Exactly. So this box here is an interesting box. Now, when you're out on a show and you're doing comm for TV event, big part of that is providing comm to the camera operators. And the camera operators usually get their comm through the camera. So they'll plug their headset right into the camera and they'll be able to hear the director, and that's all built into the truck. I don't ever have to worry about it. It just happens. But occasionally you have somebody with a jib. Now, a jib is one of those cameras with a really long arm, maybe 60 feet long, cameras at the end of it. They swing it around the room and take all. I don't have a jib. Here's my jib. And the headset is in that camera, all the way at the end of the 60-foot cable line. So there's no headset for the poor jib operator. And me as the comm person, I'm tasked with running a bell pack out to that camera to give him comm. Well, this was a box that I worked on. I had heard Keith Hall and Audio Specialties, Intercom Specialties rather, made these, and they described to me how they made them. So I made my own. And what this is just a little box. And here's the 5-pin headset on the left that plugs into the camera. And pins 4 and 5 are mixed together audio, because usually those were 2 different audio feeds in from the camera, listen audio, sometimes one with program, sometimes one, or rather camera and engineering were the 2 channels. So you had 2 different things. And then pins 1, 2, 3, 1 and 2 go to the microphone of the camera. So what this does is it takes the mic of the camera and puts it on pin 2 of this 3-pin XLR, and pin 3 of the 3-pin XLR. It runs that, takes the feed from the here. It's actually backward. So your listen, your speaker listen, pins 4 and 5 go into pin 3, and pin 2 is the audio coming from going into the camera. So this is a pad. So you're basically running line level in and you pad it down to mic level. And this is a couple of termination resistors to keep the line nice low level, and then capacitors to filter out audios. So you take this and run this XLR down the 60-foot jib till you got to the other end and plug it into a belt pack, BP 325 belt pack, adjust that belt pack so the talk button works only on channel 1, doesn't work on channel 2, and the listen is only on channel 2. Power it, replug inside the belt pack so power supply can be plugged in externally, and plug in this little push to talk button in the 1/4 inch there. And what that does is once you've turned on the channels you want to talk on the belt pack on and latch them on, alternate pushes up this button will turn the whole belt pack off and on. So you can use it to turn your mic on and off. So this was a jib kit, and these were basically built into one little box, and all you needed was that transformer and an adapter to run down there. So this, rather than run a cable through thousands of feet of XLR up to the jib, which is usually located in the back of the balcony, you would do
Because the whole point is to get audience shots.
Exactly. Now, modern cameras have adjusted that, because on a modern camera, you can go into the menu inside the camera and set it so that when you press the record button, it turns on the mic. And on a jib, they have remoted the record buttons back to the jib. That's part of the camera cable that goes between the controls on the jib up to the camera. And using a lighting, what was the name of that? DMX cable, using a 5-pin DMX cable between the camera and your 5-pin headset at the back, the comm works fine. So there's no need for a jib kit anymore. You just have to go to lighting and borrow a DMX cable, that's all.
By the way, talking about cameras and camera intercoms, I have worked for both RTS and for Clear-Com directly as an employee, and it was a huge fight over years and years for us to try and get the camera manufacturers to pay any attention to intercom.
Yeah,
because the original cameras, oh boy, I almost said they almost always have a tip ring sleeve that went to the old Telco 52 BW headsets. But actually, many cameras, I'm thinking the RCA cameras, have got the old telephone dual 1/4 inch, which was different, but they were carbon mics and not dynamic. It was just like fully.
That's what
we had at
the theater
Tech.
technology carbon mic headset used, was the dual.
We made boxes with the dual pin plug, which was the connector we could buy, and male and female XLR. Actually, is one female in and 2 male out. So the actual box was a splitter box in addition to that. So we could, but yeah.
And actually, I think one of the most popular cameras was someone help me on this, the TK47, the RCA TK47. And the intercom was a module that plugged in. And RTS actually manufactured a module that you could take out the RCA module that had the dual jacks and plug in the RTS, and it became a two-channel RTS station.
Someday we'll go back to carbon mics and we'll all be happy. What can I say? You know?
That's it. It's not just carbon mics, because a company came into existence somewhere along the line called Plantronics. And Plantronics started producing lightweight headsets, noise canceling headsets, really good headsets, but they were all geared toward carbon mics. They sort of perpetuated the carbon mic philosophy with camera manufacturers.
Well, the Plantronics were a not too good sounding headset that people liked because it was a little tiny thin cable. And I always hated them because it just made the whole system sound terrible.
Kevin Parrish mentions that the jib kit was great because it was often the case that you hired wireless comms just to do the jibs, because they were so hard to run cable too that you'd have to bring in RF comms just to do jibs. And I
Yep,
would
yep.
remind Kevin that there's a late night TV show at his network where all the cameras are wireless.
Yep. There, he asked where you buy Audio Man. That's made by Audio Man Products. So they make
Yeah,
a
just
bunch of
look
stuff.
up Audio Man, Google it. I forget the guy's name. I think it's Mark something, but I could
Yeah,
be, it could be anything.
a lot of nice little adapters he's got on his website, but obviously the Audio Man became a standard include with every single BTR at Claire and many other companies because bingo, the BTR does not need, which is a wireless intercom system, doesn't need DC into its input at all. All it needs is the audio.
Right.
Mac and you worked on the Brooklyn Bridge Centennial with me, right, Mac?
Oh yeah.
Oh yeah. So the Brooklyn Bridge Centennial was a job that had a venue on each side of the river with audience to sit in, speakers on each side of the river. We did a one night show. Was it one night or did we play for a long time? I don't know.
Played for a while.
They played for a while, a
Played
month or two.
summer.
And this was an audio.
Bonnet Lumiere.
It was a play that we recorded at Theater Technology. Actually, we recorded it blank tapes on the second floor. Mac recorded it, and we put this all together, and it was basically the story of the building of the bridge. And in the beginning, we found this company that made this magic audio lighting dimmer who could install it all over the bridge and make all the lights computer controlled. It was magic. It was great. And they convinced us they had the best thing since sliced bread. Well, that was something, and I was marginally involved in that decision to hire them, and nobody ever went to their shop to see what they actually did.
Oh,
Because we come down to 1 week before the show, and they've never demonstrated this system to us at all. And finally, somebody went and looked in the boxes on the bridge, and they were surplus boards bought on Canal Street that had been stuck in there during their installation. And some of them, they actually did build that work, but not many of them. It was a disaster. And so 2 nights before the opening show, a ton of off-Broadway technicians were hired to come in and manually wire up auto transformers all over the bridge. So they had like 6 different huts that built on the walkway across the bridge, and they all had auto transformers wired into the lights on the bridge. And strangely enough, they'd already specified that the lights be installed with pin connectors. So that was easy. They just had to plug in and they're done. And I think somehow Susie Zwerman was involved in pulling together the whole crew for that. But so we do this, and we now have to put Comm in all of these 6 different things across the entire bridge. And the bridge is about, I don't know, 1,500 feet long. And from going all the way over to the other venue on the other side. So we, at that time, the RS-100A Clear-Com box, it was a metal box. So we put 2 boxes at each dimmer, and ran across it, and Mac ran 8451 rack wire from joint to joint. We manually wired in a bunch of XLRs, and then we get down to the Brooklyn side where there's a little house right below the bridge, 400 feet below the bridge, and he drops a 500-foot reel of a rack wire down to me, and I pull it over to the bridge, and I wire it into a connector, and I put it into the thing, and I plug it into the wall, and bam, I get the shock of my life, because the bridge is at 200 volts relative to the ground in this little house. So we just ground lifted the poor little power supply and told the stage manager, don't touch the power supply. And we did the Brooklyn Bridge. But that was over 2,000 feet of wire run all the way to the cross over to the other venue where they had lights at the audience area on the Manhattan side. And as far as how long you can run cables, what's a reasonable length of distance for a Clear-Com line? I've run it a couple of thousand feet without any problem.
Yeah,
Except for that 200 volts.
It's amazing that whole thing worked on 8451, which is a relatively small conductor size.
Right.
And you didn't locally power, you actually powered the belt packs.
We powered it from the Brooklyn Bridge side, and it worked fine.
You guys must have had magic helping you, and
well, we were sort of desperate. We were like, 12 hours from the opening night with an international broadcast show, and no lighting on the bridge at all yet. So,
wow.
Our part of wiring it up was minuscule compared to the wiring up of the bridge. They literally did overnight with, it must have been 300 off-Broadway technicians. Just all of a sudden came and pitched in. I don't know if they ever got paid for that. I know I didn't get paid for it, but that was a whole nother story.
Auto transformers, you're meaning non-electronic dimmers.
Correct.
1983.
Exactly. So what cable do you suggest to replace Star Quad? Anything else? I
mean, even in analog audio, Star Quad really has limited utility. It does have better rejection of EMF. It does not have any better rejection of RF interference, but it does have better rejection of electromagnetic interference. But
yeah,
unless you're running your cables parallel to feeder cable, it's very unlikely that that's going to be a major issue. And if it is, then okay, there's a case for Star Quad, but it's higher capacitance than regular mic cable, and it is virtually unusable in intercom. It's also unusable for digital audio. There's really no point to it.
Stu Schwartz says, don't forget about the god-awful APSI console used for entertainment console. I don't understand what he's talking about, Mac. Do you know?
Well, I do remember the god-awful APSI console, but I didn't remember that it was on the Brooklyn Bridge show. That was the console that it let you know what modes you were in by LEDs behind every button, but in the daylight you couldn't see any of them.
The toilet paper tube console. We used that console for the opening of the South Street Seaport, and you couldn't see anything on this console. So we brought toilet paper roll tubes, and you look through the tube at the LED to see if it was on or off. It was terrible. So Kevin says 3,000 feet on the Today Show in Marrakesh with no problem. It worked.
Yeah, and I think we did close to 3,000 feet on one or more Super Bowls, getting up to the roof of the dome.
And John Center, he said he got paid for the Brooklyn Bridge job, and he's going to split what he got with the rest of us who didn't get paid. That's what he said.
You hear these stories, and you wonder how the show ever actually came off. It's due to the comms people. I've always said.
Well, it's not only comms. I mean, literally, this particular show is the bridge was a disaster from the beginning, and all the money got eaten up putting in the actual physical lights on the bridge because they had to be special lights. They had to be rated for permanent installation. Each box where the computers went was $10,000 just for the box installed. So it was a disaster, and they spent all the money on that, and in the end had no money to pay for the rental of the comm system or the other stuff we did. So back.
But Pete, you did get to climb up the cables to the top of the Brooklyn Bridge.
Yeah, I had to personally go advance the top of the Brooklyn Bridge. But I went up there with the Grucci's to look at where they were going to mount all of their lights and their
fireworks.
pyro, and it was a truly amazing climb. I really, really loved it. When they gave me the opportunity to climb up to the top of the bridge, I just jumped at it. It was great.
And I jumped completely the other way.
There we go. There we go. What's a little height between friends? So this is a current power supply made by Clear-Com, the MS704, and it is a 4-channel power supply, 4-channel intercom supply. It's a single power supply, but the 4 channels of power that come out pin 2 of all of these outputs on the back are basically all just wired together. They're not isolated. Pin 3 each has a separate termination switch. You can see the termination switch right next to it. So if I had multiple power supplies on this line, I could turn off the terminations on. They were extra beyond the one I needed. So this is their basic power supply. A slightly different version is the same thing, except it has a little dial up here on the side. So you could select each of these 10 outputs on the back to one of the 4 channels and off, which was a separate isolated channel. So basically you could make 10 channels of comm if they were all off, or dial them up to different channels together and make them a group channel. This is the Clear-Com power supply. I mean, the RTS power supply, PS31. Go ahead.
Before you leave the last 2, I would just like to, I think, make a slight correction. To the best of my knowledge, those are master stations. They are not power supplies. Clear-Com had 3 different items. It had a power supply, which only provided power and did not have any communication capability. It had remote stations, which had no power, had to be powered externally, and it had master stations. Master stations had both communication capability and power capability. And the SB412 says switchboard. What does that one say, Pete?
Well, the MS704 does have power. The MS704 does have power, but the SB704
does have power.
It has power also, because you can tell by the short LEDs on the left-hand side. But yes, they also made versions of the MS without power.
Yes.
Now the problem with those is I experienced in an installation in Chicago. Epic Pharmaceuticals had a giant theater with a Clear-Com system in it, and it buzzed like the dickens. And they just lived with it. They didn't know what to do with it. So what they did is, what I did when I came in is I went around and unmounted every station from the rack in the entire system. And when I got to the last one, unscrewed the rack screws, pulled it away, buzz went away. So I just told them to remount everything on rubber screws or something, and it would be fine. Because the case, the steel case of this was common with the ground on the intercom supply. So they were all over the place in terms of ground potential. So back to the RTS PS31, one of my most famous, terrifying events in my life. I was the front of house mixer on the Republican convention in Dallas. And we had a big RTS system, lots of RTS power supplies. And they were all in a room underneath the stage, right underneath the dais and or the stage. And there was one single room run across the entire stage that accessed all the different rooms underneath the stage. And one of those rooms was our comm room, and that we put the comm system in there. And the day before the convention was supposed to start, Secret Service says we could no longer use this pathway underneath the stage. So they screwed our door shut and cut a hole in the wall in the back of our rack. So literally our racks were against the back, and you had to sort of squeeze along one side of the rack and go through a hole in the wall to get out of the space. So I'm sitting up there at front of house, ready to start. My mix position is as far stage right as you could imagine. I was up against the back of the building, 400 feet to the stage, and I was mixing off of a sort of a speaker above my head. They didn't want to have front of house mixer out in front of house, obviously. So I'm sitting there, and all of a sudden my console just goes black. And I get on my radio, which luckily was not plugged into the wall. I said, just lost power. And then it came right back on. And after the show, I found out that the person in the rack room under the stage, where all of these power supplies were, heard the power supply give its death knell beep. This little switch on it here says audible alert. And when the power supply loses power, it goes beep, 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 beep. And he heard 6 of these in the rack do that noise, and he dove behind the rack, and somebody had come in to ask us if we wanted lunch and had hit the main power for the entire room. He just dove behind the rack, switched it back on, and therefore that saved the entire Republican convention from at least an embarrassment of starting the show. This is the back of that power supply, and another feature of this power supply, which I wish they would correct, is that this program input on the left here, which is the volume control, and you can switch it between channels 1, 2, and 3 of the power supply, and the audio goes in the back here on the far right. If it's turned up full, you get hum on that channel if there's nothing plugged in. So it's basically a tone generator for those channels. So you got to make sure that your program level is turned down. On the back of this power supply, it has 3-pin XLRs, which have 2 channels on each. So it's because it's a 3-channel power supply, you have pins 1 and 2, channels 1 and 2 on the first 2, channels 1 and 3 on the second 2, and channels 2 and 3 on the third set. And then on the right-hand side, you have the same thing with all 3 channels on 4-pin connectors. And that's what we'll talk about on the next show, where we're going to talk about taking all of this great 2-wire comm and making it into a useful system, something that is on a show and we can actually use it creatively. This is a smaller RTS power supply, which actually I think has more amperage than the PS31, but it's only a half rack. It also has a capability to be switched between Clear-Com and RTS 4-channel or 2-channel. It's a very powerful little power supply, but this is their main product offering right now. So this is basically what Comm is all about. Let's see if we have any questions here. The SB7042 power supplies, it might. I'm not really sure about that. The XLR outputs on the PS31 are non-locking. I do not understand why they did that. I guess they were afraid of getting a cable stuck in it.
I have lots of equipment here at home with cables stuck in it. I just took them to work the other day because I needed one more mic pre, and I have a 2-channel mic pre that has a nitric connector stuck in the back of it, so I could get 1 channel out of it.
Now, this rack that you're looking at on the screen right now is a dial-up 2-wire system I built for Wireless First, and it has a rack of power supplies. It has a rack of this particular thing I think is in-ear monitors or drawers, right? But it also has a thing called a dial-up, which allows you to take 16 channels or 26 channels.
Right, 26 ports with 26 each one ports, has 15 channels plus off.
Dial up to the 15. So it gives you flexibility, and it all goes through a patch bay, and this patch bay takes each one of these things into a different set of multi-plugs on the back. So I think they were MS-11s or something like that, 11-channel multis. You could plug in the back and run to different parts of the stage, and then just dial up on this dial up, or use patch bait to get special things down the line for running comm all over the stage. The Kenneth asks, have we used large quantity of intercom on 4-channel XLR? Yes. To shielded Cat5, not wet. Shielded Cat5, because it is Cat5 is basically 110 ohm cable, so it's useful if you're running AES cable on Cat5. So I've done that with Riedel C3 belt packs run on the XLR to shielded Cat5 adapters. Have not run it. Have not used wet comm on those.
I mean, it does allow it if some of the box, not all of them, but most of the boxes allow it as long as you have shielded Cat5 to supply the ground return.
Right.
Now, but it's still all tied together.
Back to the Atlanta Olympics. I was working for Keith Hall on that, and they gave me the job of doing the comm at the kayak, the whitewater rafting kayak event, and it was actually in Tennessee. So it's not actually Atlanta. I was in Tennessee, a long drive from Atlanta. So we never had, or hardly ever had, any Olympic people come to our venue. We were in this little valley, tiny valley, and you'd come in the morning, the river would be bone dry, and at 9 o'clock, whistles would blow, and inside of 30 minutes, you'd have raging river coming down the water, because the entire river was run by the Tennessee Valley Authority, and they had dams all over the South. They could turn off anybody's river if at a minute's notice. You know, if you don't send your kids back to school, they're going to turn the water off in your river. So what can I say? So when I came in on the job, they had already pre-wired the event with 25 pair telco. So I had a 25 pair telco that went down one side of the river, stopping at each place I had to put a comm, cross a little bridge down at the bottom, and up the other side of the river all the way. So it's about maybe 1,000 feet of 25 pair cable. And I was doing 2-wire comm. There was no shielded wire anywhere. I had to use this 25 pair telco. So I just figured, well, we'll see what we can do. So I go in and I would use a twisted pair for pins 2 and 3 and another twisted pair common together as the ground. And I would wire them up. So I had 12 circuits run all the way around on all sides. And I would put XLRs on those at each one of these. And what it was is at each set of gates during the race, they'd have judges on both sides of the river that had to talk to each other and to the director of the show. So I had to connect pin 1, channel 1 of this bell pack had to be the director. Channel 1 of both of these had to be the director, and channel 2 had to be the other side of the bridge of the water. Now, you think it would have been easy since the river was drainable just to run a cable across, but they didn't want to do that. So I wired it all up, and I wired it into the trailer where all the TV stuff was, and turned it on, and you could talk back and forth fine, but it was pretty bad buzz, hum more than buzz. And I'd used about half of the circuits in the 25 pair. I was only running 12 circuits around for the 12 different gates. And I don't know what made me do it, but I just on a lark decided to ground every other cable in the 25 pair. Bang, the buzz went away. So it worked out perfectly. And now you know it. It's not that you have ground or shield around your cable. It's that you have enough mass of wire to suck off the hum that's being induced into the cable around it. So Andrew was asking you, Bob, why the XLRs are not locking.
Oh, no, that was, I made a mistake oh, why the XRs are not locking, or the female male thing?
No, why the
locking-
XLR outputs
locking
are
system.
non-locking.
Oh, well, that's really a very good question. I have no idea.
Okay, fair enough.
The
Well,
next question?
that's everything you ever wanted to know about two-wire, probably a lot more than you cared about two-wire. And I'm glad we had a few stories to tell you along the way. We will have another show coming up on Thursday, which, like I said, is about what you see on the screen right here. This guy right here is not me. This guy's only 6 feet tall. I'm 6'2". So I had to use a stand-in when I took this picture, and he was the guy that worked in the shop. So we're going to talk about this particular rack and how it basically all works. I want to thank Bob for coming and being a part here. If he's available on Thursday, I haven't asked him this yet. Maybe he can join us too and talk about it, because this is the real power of the system, the dial-ups. And when I first started in the business, Bob was doing the comm on all of the Super Bowls, and they were all done until the Super Bowl in Salt Lake City. They were all two-wire RTS everywhere. And I tried to find Bob's dial-up. Mac had bought it at an auction,
And I don't know where it is.
and
There
we don't know
was
where
a photo of it recently, wasn't there?
Yeah, I'm sure there's a photo somewhere.
but it was a very unique dial-up. It was about maybe 6-7 rack spaces, and it had rotary dials across the top that dialed 1 through 12 position rotary switches, 2 rows of them, one for channel A, one for channel B, and then right below it was a column of XLRs that were all wired in parallel, and a single extra XLR. And what allowed you to do is dial up on this particular output, channel 1 and channel 2, into the bell packs, and then plug all the different multis you have from coming all over the different venue into that column. And that was what it was all about. And Bob made this box, and we used it for years as our main dial-up.
It had voltmeters on all of the
Yes.
inputs, so you
Every
could
input had a
power.
voltmeter, right? Yep.
And it had a whole switching system on the back for routing. Geez, I don't even remember now, but there was a lot of routing on the back of the box.
Yeah, it's really strange how it's amazing to me what we were able to accomplish with two-wire intercom.
Yep.
That now in the digital matrix intercoms, you sit down and at a computer and make it happen. But on the big shows like the Academy Awards and what have you, how much tape did we use labeling the PL cables 1 and 3, 2 and 4? So
Right.
you knew what they were. And I'm just curious, Pete, if you're going to mention it the other time. There is one, I think, other very unique job we did that involved all two-wire, but involved all four-wire. And we did President Reagan's inauguration.
Oh yeah. This was a show where every inaugural ball was part of one giant show.
It was a venue in itself, had an entire mobile unit. It could have broadcast totally from there. But all of them came together in the master control truck under the Kennedy Center.
But they were all connected using a 4-wire Biscuit. You didn't actually connect into our comm system. You connected we just had a 4-wire Biscuit which had Bob on it, and we just talked on it, and the director was on it.
Were you in Air and Space?
Air and Space, yes.
Okay.
Yeah,
Well,
I was there too.
Yeah, the thing was, we needed the communication between the venues, and it had to be provided by telco because we didn't have radio and wireless capability like we do nowadays.
Yep.
And So we had to order up from telco. I think, let's see, there was a broadcast audio send, a backup send, production. I think there were 8 pair. We needed 8 4-wire circuits
Right.
between central control,
Right.
and they said, we don't think we can do it. And in
Yeah.
all the discussions, finally we said, believe it or not, actually I said to them, I said, is there any chance, because it had to do with repeaters, I said, is there any chance you could give us hard copper connections between all the venues?
No amplifiers.
No amplifiers, nothing, just hard copper, a piece of wire from Air and Space Museum to Kennedy Center. And they said they could. And we had a massive rack of 4-wire interfaces where we took the telco 4-wire and converted it to 2-wire and assigned it to where I had to. And I must admit, it was funny for several years afterwards, particularly in Los Angeles. There'd be some show that had nothing to do with anything, but suddenly on the PL, you'd hear someone say, Air and Space, can you hear me? Air and Space?
Oh yeah. Oh, definitely, definitely. Kevin Parrish and Brew thanked us very much for this show, the history and that kind of stuff. It's amazing what you can do on with digital systems that we had to suffer through with the 2-wire. I want to give a special recognition to the one person who has made the entire intercom industry possible. That's Judge Harold Green, who broke up AT&T. Before that, every intercom system was run through AT&T. Comm systems and NBC, CBS, ABC all had to be run through AT&T because they had an exclusive on it.
All dial-ups.
One final thing, if I may, at least for me. I think we've all experienced this, but those of us who started out in the 2-wire, very simple, there was a production channel and a lighting channel and a sound channel. But then somewhere along the line, someone said, well, can we have a follow spot channel also? So we give them a follow spot channel. And then they'd say, oh, we've got a lot of scenery movement. Could we have a channel? And we have a reputation of providing communication, providing any communication they want. And it has grown exponentially because we've been able to provide it to them. And every time we provide it, they say, can we do this? And now you look at the communication on something like an Olympic opening and closing ceremony with all the wireless and the radio and everything. It's astonishing that it all came out of a single channel belt pack system, and it just exploded. And yeah.
What I like is now the systems are so versatile, I can make the show so complicated, nobody can figure out how it works except for me. That's all.
That explains all the jobs I see you having.
Yes, Henry, I did have an audio channel. Anyway, thank you very much, everybody. And on Thursday, same time, same place, we're going to do this thing again, and we're going to talk about the real world. Again, thanks to Steve Savanu for the interviews with Mr. Buttons. And this will be on a video on our website by tomorrow. And certainly all of the handouts.
Also on YouTube.
Right, on YouTube, and all the handouts, including this PowerPoint deck, will be on there as well. So thank you very much, everybody, and have a nice day. I'm going to go outside and enjoy a little sunlight. Amazing.
Yeah, me too.
6 feet away, of course.
I'm going to enjoy the night.
Well, you're on the wrong end of the world there, you know. What can I say? It's probably, what, 9 o'clock at night there or something?
No, it's
no, it's not quite that bad. It's
7 o'clock. It's either 6 or 7. I can never remember which.
We're going to do a webinar on reading a clock coming up later on, I think. So good night, everybody. See you later.
Bye-bye.
Good night, everyone. Good night.